Hey, how's everybody doing out there? Hey, precalculus! Welcome. It is an exciting afternoon because in how many days do we have until what we've been preparing for the whole year? 7 days! 7 days! Oh my goodness, 1 week from the day. 1 week. Whew, man, it'll be all over. So this is the last show of the year. Okay, I hear the tears falling down now in the entire city of Dallas on the B cable. But today we're going to go over something that's always on the exam, and that's PVA problems, position, velocity, acceleration problems. Try to throw in a few little twists for you, so in case anything challenging does come your way next Thursday, you will be prepared. But I think in the last 20 years, about 17 or 18 of 20 years, they have asked a position, velocity, acceleration question. So it's pretty likely that they'll ask another free response. So this is pretty important. This, along with what we did last week with the graphical analysis, first, second derivative, is just about as important as you get. And we have the big cookie!
Pickles!
What's going on?
Not much.
Not much? Okay, you ready for a problem? Tough problem.
Oh, yeah. Yeah, big cookie's always ready.
Okay.
For calculus.
There you go. There you go. Okay. We're going to start you off.
Okay, first of all.
Okay, wait, hold on. Let me talk for a second here. Yeah, I left out in all these problems, this is a particle's moving where the velocity is equal to this.
Uh-huh.
And at time equals 0, the position x sub 0 is equal to 1. So tell me what the acceleration is.
Okay, all of the acceleration is the derivative of velocity. So you do the product rule, which would be x first term times 2x cosine x squared.
Wait, tell me again.
Wait a minute. No, it would be negative 2x sine x squared.
That's right, because the derivative. Okay, good.
And then plus the cosine of x squared, because it's the second term times the derivative of the first term, and the derivative of x is 1. Now, to clean that up.
You want to clean that up?
Yeah, could you zoom in on zoom in? Yeah, just a little bit. Okay, thanks. So now it'd be, the cleaned up version would be negative 2x squared sine x squared plus the cosine of x squared.
Excellent job. Excellent job. Hey, fine job here. I don't even have a bell. I'm going to look for a bell, but
yeah, I want my bell. Thank
got
you.
It, all right. Hey, call it again, all right? We got some challenging problems for you today, all right?
Yeah. Bye.
Bumika Kapadia!
Hi, Mr. Fly.
How you doing?
Good, but I can't see you.
Why can't you see me?
Our TV's messing up.
Really?
Yeah.
So,
you're just flashing
So
by.
how are you going to do the problem then?
I don't know.
Okay, well, write this down.
I need a pencil, someone.
Can you see that?
Uh-huh.
You can't see that?
Yeah, it just came back.
Oh, it just came back. Ah.
Uh-huh.
So it just, maybe it's not the TV, maybe it's me.
No, it stopped.
Okay. Fine. I want you to do question number 2.
You integrate it.
Why do I integrate?
Because it's PVA, and to get to position, you have to integrate velocity.
PVA, baby! PVA! So the integral of the velocity is equal to the position, which is equal to the integral of x cosine of x squared.
Right.
And how do I integrate the x cosine x squared?
You set u to equal u to be x squared. So you're left with the 1/2
Okay.
integral sine, 1/2 integral sine, and of cosine
1/2 integral of cosine, okay,
of u
of u.
times, yeah. And so it's 1/2 sine of x squared plus c.
Excellent job. 1/2 sine of x squared plus c. Bhumika Kepadia, call in again. We got lots of fun stuff going on, all right?
Okay.
Hey, Scott.
What's up?
How you doing?
I'm doing okay.
Well, I'm glad.
You guys do any VC stuff today or just AV
Well,
stuff?
let's see if you can do this.
I don't know.
Let's see if you can do this here. All right. I want you to find the average velocity from t equals 0 to t equals square root of pi.
I believe that's 1 over b minus a times the integral of a to b of the velocity.
Okay, excellent, excellent. So therefore, it's 1 over square root of pi minus 0 from 0 to square root of pi of x cosine of x squared. Okay, and how do I do that?
You integrate.
We integrate, and that's excellent. And Bhumika Kepadia already told us what that was, which is 1/2 sine of x squared, 1 over square root of pi from 0 to square root of pi. If I plug in square root of pi into, what's sine of pi equal to?
I don't know.
Take your time,
Zero.
relax. Zero. What's sine of 0 equal to? Scott? What's sine of 0?
Zero.
It's 0, okay?
I
So
don't
it's,
know this stuff.
so it's 1 over square root of pi times 0, which is equal to 0. But wait a minute here. How is that possible? How could the average velocity be 0?
It's going up and down at negative positive all the time.
That's right. So on the average, the velocity, exactly, it's moving to the right and moving to the left, and on the average, it's equal to 0. Scott!
Yes.
Fine job, Scott. Fine job. You ready for next week?
How many days left?
7.
7.
You ready?
I'm ready.
You gonna be there Saturday?
I am.
All right. I'll look forward to seeing you then.
All righty.
Call in again. All right. Have somebody in the background call in.
Okay.
All right. Good job, Scott. Andrew Rogers?
Yes, sir.
What are you doing?
Watching you on TV.
Oh, you have to be. What are you doing beside that? Or like, how's everything going?
Woodrow's about to kick the crap out of Hillcrest in baseball today.
It's as this is live TV. I don't think kicking the crap is appropriate for our sponsors. I don't know. I think Woodrow's record, if I saw in the paper, was 8-13 on the year.
Yeah, but it's a lot better than that when we come against
I'll
Hillcrest.
tell you what. Do you want to have a little side bet on this game?
Sure.
Okay. We'll bet. I don't think I could.
You're on live TV now.
That's right. I know. So we have a tape. I'll tell you what. If Woodrow wins, I'll just buy you pizza on Saturday.
That'll work.
Okay. Are you coming Saturday?
Yes, sir.
All right. There you go. All right. Try this one. Here's a good problem for you.
Okay.
Same stuff. Velocity is equal to this. How do you find the total distance traveled from t equals 0 to t equals square root of pi?
It's the area under the velocity curve.
Okay, the area under the velocity curve.
Mm-hmm.
Okay, so
Use the formula v of t equals x cosine of x squared.
okay,
And you're going to integrate that from 0 to square root of pi.
is Mr. Irby in the room?
Yes, I think he is.
Ask him if you're right.
Am I right? He's coming to look.
You mean he's not watching until?
No, I'm not.
Okay, because for total distance, one thing we got. Hey, Andrew, if you if you go to where are you gonna go to college in a couple of years?
Any place that'll pay me to go.
Okay, if you go to Brookhaven, and
El Centro.
if there's nothing wrong with Brookhaven or El Centro, but if you go to Brookhaven, 20 miles and drive back 20 miles, how far did you travel?
40 miles.
But how far did you actually move from where you originally were?
0.
And that's what this area does, because it takes the stuff above the x-axis, subtracts below the x-axis. So for total distance, you have to find out where the velocity is equal to 0.
Right.
Okay, and how can we find that?
By setting x of cosine of x squared equal to 0.
Okay. Okay, then what do we do?
Solve it.
Well, tell me how to do that.
Cosine of x has to equal 0, and that's at pi over 2.
Okay, so cosine x squared equals 0 is when x squared is equal pi over 2. So it's when x is equal square root of pi over 2.
Or it's also at x equals 0.
Right, and so since we want it from 0 to square root of pi, it's already an endpoint.
Right.
So how would we know, is from 0 to square root of pi over 2 positive or negative? How would we know? Like, we know that the graph either looks like this, it looks like this, where this is square root of pi over 2, or it looks like this. And that would depend how we set up the integrals. How would we know which one it is?
By picking a point between the two and seeing if it's about positive or negative slope.
Okay, so what point do you want to pick?
Square root of pi over 4.
Hey, that sounds reasonable to me. So it'd be a positive, and the cosine of pi over 4 is a positive, so therefore it looks like this one.
Right.
So how would you set up the integral to solve this problem?
You do the integral from 0 to pi, square root of pi over 2 of x cosine x squared dx, and then you subtract the integral from square root of pi over 2 to square root of pi of x cosine x squared.
That's excellent. Now, okay, and then and the integral, as we already found, was 1/2 sine of x squared. So it's this, square root of pi over 2 minus 1/2 sine of x squared from
Square root of pi over 2 to square root of pi.
Okay, and if you plug square root of, what's the sine of pi over 2?
0. No, 1.
It is 1. And so it's 1/2 minus 0 minus, and what's the sine of pi?
0.
What, and so it's 0 minus 1. So therefore you got 1/2 minus negative 1/2. So therefore the total distance traveled would be 1.
Yes, sir.
Wasn't that pretty exciting?
Very.
And when Hillcrest Run Rules Woodrow today. Hey, call it again. Good job. Hey, Andrew, you really should do that for those practice problems in the blue binder, because you know, there's no way you won't get a 5 if you just see what's on the test.
All right, man.
Good job.
Thanks.
Annalisa, dormez-vous, dormez-vous.
Hi, Mr. Fox.
I heard that in the background, her saying, "Oh my gosh." How you doing? You seem in a much better mood this week.
I am.
Well, that's good. Well, can I try to get you in a bad mood again?
No. Miss Arthur says no.
I hear that. No, she said no. Okay, we're going to give you actually, it's a really hard problem. Don't laugh. This is a graph of the velocity. Okay, and the velocity is made up of a quarter circle and a line. Quarter circle and a line.
Okay.
So tell me what you think the average velocity, well, I'll tell you what, I'll let you pick either one of these. You could pick the total distance traveled or the average velocity.
Total distance?
And David from Hillcrest will do the other. You could pick whichever one you want.
Okay, total distance.
Okay, you're going to pick total distance?
Can you bring it closer? We can't see because the TVs aren't doing very well over here at Cougarville.
Cooperville?
Cougar. C-O-U-G-A-R.
Cougarville. Okay.
Right.
Can you see that?
Yeah.
If that's the graph of the velocity and this is a quarter circle and that's a line, what's the total distance traveled? If that's the velocity. In general, how do you find total distance traveled?
You take the two pieces and add them together.
Only if what, Annalisa?
If one's below the axis.
If one was below the axis, like if it looked like this, if it looked like that,
yeah.
How would it be different?
Yeah, you separate them, you integrate the top and you integrate the bottom and you separate them and add them together.
Okay, but you would subtract the bottom because it's negative, right? But since the velocity is always positive here, the velocity, it's always above the x-axis, it's always positive. The total distance, you'd add just the two areas together. If it looked like this, you would take this area, this integral, and subtract that integral, and you would get it. But this one, okay? So what's the area of this region in here if this is a quarter circle?
You use the 2, right? I mean the line to 2. Okay.
Well, I just want to see this.
Pi r squared, because you have your radius.
Okay.
So it's pi times 2 squared.
Which is,
times 2 squared.
So what's 2 squared?
What? Oh, 2 squared is 4.
So if the whole circle would be 4 pi, what's the area of this quarter circle?
1/4 times 2 pi.
1/4, which is just
Sorry.
pi, okay? And what would the area of this be?
What's the little end point? I can't see.
That's a 2.
4? No,
Yeah,
but on the
that's a
inside?
4, that's a 2.
So it's a triangle, right?
Yes, ma'am.
And your bottom is 2, and your side is 2. So your hypotenuse is, doesn't matter.
Area of a triangle, Annalisa.
Oh, okay. So base times height is 4 divided by 2 is 2.
Okay, so the answer is just pi plus 2 for total distance.
Yes.
Isn't that exciting?
Thrilling.
Fine job.
Thanks.
Much better, Bell. Call in again, Annalisa. See, is this David Kent?
Yeah,
How you doing?
pretty good.
You gonna be there Saturday?
Like 2 days from now?
Like 2 days from now. Today's Thursday and 2 days. Saturday.
Yeah, maybe.
Okay, we're giving away free stuff.
Again?
That's right.
Are you still going to not want to give it to me?
I'll never want to give it to you. That's right. Hey, David, how would you figure out if this was the velocity function? What would the average velocity of this be? How would you figure that out?
Hold on, Scott's laughing at me because this is like the thing that I'm not good at. All right, wait, what? How do you find the average velocity?
If this is a quarter circle, that's a line. Yeah, how do you find the average velocity here from t equals 0 to t equals 4?
The integral from 0 to 4 of v of t over 4 minus 0.
Okay, because
So
average, it's the average value, so it's this from 0 to 4 of the velocity. And Annalisa Calvert from Brian Adams just figured out what this was. You remember what this was?
Yeah, 2 plus pi?
Or pi plus 2.
Pi. Oh, sorry.
I'm just kidding. Pi plus 2 over 4 is the answer. That is a fine job, David Kent. A fine job. You know, don't let Scott tell you any different. I'll give you a harder problem when you call in again, all right?
All right.
Good job.
Okay.
Mr. Bowser,
Hello.
how you doing?
All right.
All right, you going to be there Saturday?
Yeah.
Yeah. You excited?
Yeah.
There you go. I feel it. I feel the excitement, Dennis. I feel it. Okay, here you go. A little harder problem here. I got to cover some things up here. Don't want to give away the answer. All right, Dennis, here you go. If, once again, you have this particle moving where its acceleration is -1 over t squared. At time t equals 1, the velocity at 1 is equal 4. The position at 1 is equal 3. Tell me what the position is.
The position function?
Yes, in terms of t.
Well, we take an integral to get velocity.
And I'd actually write it out like this, okay?
So we end up with 1 over t.
So it's the integral of negative t to negative 2. When you integrate that, it's negative t to the -1 over -1, which is just -1 over t.
So it'd be 1 over t.
I'm sorry, 1 over t, right. Just check and see. What else is missing? What else is missing beside that?
Plus c.
Plus c, okay. So that's the velocity. What do we want to do from there?
We're going to plug in 1 for t and set it equal to 4.
So 4 is equal to 1 plus c, so therefore c is equal to 3. Good. Excellent. So the velocity is equal to 1 over t plus 3, right?
Yes.
Okay. And what do I do from there?
We take another integral to find position.
So the other integral is is 1 over t plus 3. And what is the answer to the integral of 1 over t plus 3?
ln of t plus 3t.
ln of t plus 3t plus c. And then to get rid of the c, what do we do?
Plug in 1 for t and set it equal to 3.
So 3 is equal to natural log of 1 plus 3 plus c. What's natural log of 1 equal to?
0.
So what does c equal?
0.
So excellent. That was too easy. X of t is equal to natural log of t plus 3t. A fine job, Dennis. Hey, is Butters there today?
No. No, I don't see her.
Where's my dairy product?
I don't know. Larry's here if you want Larry.
Hey, no, we'll come in. We'll get back. No, it's okay. You could call again. But when's Larry's race?
Tell him I'll race again against colleges.
He's racing this weekend against college. guys.
College guys?
Yeah.
That's not fair.
He knows.
Did he go to state? Did he run at state yet?
No.
What is that?
He didn't make it. Change the subject.
Okay. All right. Hey, Greg, call in again, all right?
Okay.
All right. Rachel Kelly?
Yes.
Oh, no. Sound more enthusiastic than that.
Yay.
How's your eye? Is your eye better?
My eye, no, it's still there. I've got a big red dot chilling.
What happened?
A blood vessel popped.
Ow.
Yeah. It's exciting.
Well, what does Alex say about that?
You know, I don't think he's mentioned it.
Okay. Well, if he does, tell
I'll
him.
hit him for you.
Okay.
Okay.
All right, same problem that we just did. And Dennis Bowser from WTY showed us that x sub t is equal to the natural log of t plus 3t. And he also told us that the velocity was equal to 1 over t plus 3. So how would you find the average velocity, Rachel Kelly? The average velocity from t equals 1 to t equals 4.
that pop goes the weasel thing, the 1 over b minus a, right?
Well, tell me what to do.
It's 1. I can't see the numbers.
Okay.
Is it, are the bounds 1 and 4?
Yeah.
So it's 1 over 4 minus 1. And then you integrate. And the function, it's, isn't it the
Which one? You got
The
3 of them to
velocity.
choose from. Are you sure?
yes.
If you want to find the average velocity, then you would just do that, right? So
Right.
it's 1 over t plus 3. And wait a minute here. We probably could do this. So tell me what to do from here.
Okay, it's 1 over 3. And then you integrate it. And then it's t.
What's the integral of 1 over t?
Oh, it's the natural log. Yes.
It is natural log. And what's the integral of 3?
3t.
And we actually had that right here.
Right.
Okay, good.
So you plug in 4, the natural log of 4, plus 12, minus the natural log of 1, plus 3.
And what's natural log of 1 equal to?
0.
So therefore, we have 1/3 natural log of 4 plus times, or plus 12 minus 3 is 9. Right?
Yes.
That's a fine job.
Thank you.
Rachel, was that too easy for you?
No. Wait, what did you just say?
Was that too easy for you?
No.
Okay, well then let's give this one if that wasn't too. Let's try the total distance, Rachel.
Miss Arthur. Okay. Total distance. I got it.
Total distance, you got it. From t equals 1 to t equals 4.
Uh-huh.
No, without Miss Arthur.
Yeah, she's not in the room. She can't really help me now.
All right, here you go. Well, to find total distance, what do we do, Rachel?
What do you do for Don't you integrate the velocity?
You sort of do, but there's one thing you need to know first.
If it's negative or positive.
Right, you have to find when the velocity is equal to 0. So
Right.
when does the velocity equal 0 here?
Hold on just a second. I gotta think about this.
Okay, well, what is the velocity, Rachel?
Like, are you asking for the equation?
Yeah.
It's the 1 over t plus 3.
Okay, so we want to know when this equals 0, so what would you do?
You plug in y. Does it? Wait. Yeah. You set it equal to 0.
Right, you said it equals 0. Okay, and then what do we do?
And then you solve for t.
Tell me how to solve for it.
Okay. You put the 3 on the other side, so it's 1 over t equals negative 3.
Mm-hmm.
And then you, it's t equals negative 1/3.
So t is equal negative. So that's when the velocity equals 0. How does that help us over here?
You have to have 2 integration equations.
Why?
So that if it's negative, then it doesn't mess up the answer.
Okay, so which 2 do you want me to have?
Is it? I don't know. I'd say, was it 1 to 0?
Well, this says from 1 to 4. We want the total distance from 1 to 4.
Oh.
And we know the velocity is equal to 0 at negative 1/3.
Does it matter? Is it negative 1? I don't.
You're right. What's your instinct?
That I don't have to worry about it.
That's right. It's not between 1 and 4.
Good.
So between 1 and 4, it's always positive or always negative. And we plug in a number like 2, you'll see 1/2 plus 3 is positive. So all we have to do is to integrate from 1 to 4 of the velocity because there's nothing negative in there.
Right.
So therefore, I'm going to give you a problem in a second, though.
Okay.
And you already integrated this, and you can do that. Tell me about this. So let's say the velocity. Let's make this simple as t minus 3, and I want to know the total distance traveled from t equals 1 to t equals 4. If this is the velocity, how would I find total distance traveled from t equals 1 to t equals 4?
You integrate it with those bounds, right?
When you find total distance, what do you need to do first?
You need to know if it's negative or positive.
Okay, so
you set it equal to 0.
Okay, and then what does that tell us? When it equals 0,
That t equals 3.
that t is equal to 3, right? Okay, now what does that tell us?
Oh, okay, so you have to have 2 integration problems?
Right, because it's equal to 0 in between there, right?
Right.
Okay, so which one's going to be the plus and which one's going to be the minus?
I don't understand what you're asking.
Okay, well tell me what to do.
Okay, so you have 2 problems and you integrate them from 1 to 3, and then the other one is from 3 to 4.
Okay, but one of these we're going to subtract. Do you know which one we're going to subtract?
The second one. No, I probably guessed wrong, right?
Yeah, but let's show you why.
Okay.
What you do is you take the steps to find total distance, and you're doing fine, Rachel. You find out where the number 1, find out where the velocity is 0, and then find out where the velocity is positive and negative. From 1 to 4, from 1 to 4, from 3 to 4, if you plug in 3.5 into the velocity, it's positive. If you plug in 2, it's negative. So it's this integral from 3 to 4 minus the part where it's negative.
Okay.
And that's what you do. Okay, I'm going to give you another one here. You ready?
Okay.
And we're going to do it in a second here. We're going to do it. Let's just keep it simple like here. How about v sub t is equal to t squared minus 4 for t greater than 0. Find total distance from t equals 0 to t equals 3. Okay? So tell me. What do I do?
Okay, you have to see if it's negative. So you set it equal to 0.
Okay, so it's t squared minus 4 is equal to 0.
Right, so it's like t plus 2 and t minus 2.
So t plus 2 and t minus 2.
Uh-huh.
Okay.
So it equals 0 when t is plus or minus 2.
So t is equal plus. How does that help us over? Okay, how does this help us in the problem?
Well, the positive 2 is in between the 2 bounds. So, right?
Right. So what are we going to do?
You have to have 2 integration problems. You have to add it.
Okay. So which one do I do?
Okay. 2.5. Hold on. So if I add 2.5 and I square it, so that's more than 4. So it's 2 to 3 minus 0 to 2.
Okay. And that's excellent. Okay, Rachel.
Yeah.
I'm going to give you a little twist on one now.
Okay.
Do you have your graphing calculator?
Yeah, we have one right here.
Okay. I want you to do this problem. I want you to do this whole problem. Just you and me, baby.
All right.
Okay.
I'm excited.
I want you to do this whole problem. Take your time. If you can do this problem, you're in really good shape from start to finish. But you get to use your graphing calculator. Now, if you have a TI-89, I wouldn't let you use it on number 1 or number 2, but
I do have one.
You have an 89?
Not with me, but it's at
okay,
home.
but no, this problem wouldn't be asked. It would be changed a little bit if there was an 89. But I want you to go through this whole thing with an 83.
Okay.
So tell me what to do for for number 1.
Is that the acceleration?
Yeah. So how would I find that?
TVA. You derive.
Okay.
So it would be ET minus 4.
Okay. And what about the position?
You integrate.
Okay, and what's the integral of e to the t minus 4t?
It's e to the t minus 2t squared.
What are we missing?
Plus c.
Okay, good. Okay, so far you're 2 for 2. How would we? Well, how do we? Well, how can I use this to find c?
You plug 2 for y and 0 for t.
Excellent. So it's 2 is equal e to the 0 plus 0 or minus 0 plus c. So what's e to the 0 equal to?
1.
So t is equal to 1 plus c. So therefore c is equal to 1.
Right.
Okay, if c is equal to 1, then the position is e to the t minus 2t squared plus 1, right?
Uh-huh.
Okay, now let's do the last two.
So it's like the 1 over b minus a, right?
You tell me.
Yes, it is. I'm telling you.
Okay.
So it's 1 over 1, so it's 1, and then you integrate it from 0 to 1, and it's, okay, e to the t minus 2t squared, right? Is that the one?
Which one? No. Tell Miss Arthur that you're doing well and you don't need her help.
I use the velocity one, so it's
That's right.
e to the t minus 14.
Right. You're doing great. Don't get any help, Rachel. You're doing great.
Okay.
Okay, so what do I do from there?
Okay, so then you integrate. So it's 1, integrate from 1 to 0. It's e to the t minus 2t squared.
Okay, from 0 to 1. So the answer is e to the 1 minus 2 minus e to the 0, which is 1 minus 0. So the answer would just be e minus 3.
Okay.
Okay?
Mm-hmm.
All right, here you go now. Total distance.
Okay.
I'll give you a hint. You got you. Well, we'll go. I'll be quiet. But you can use your graphing calculator here.
Okay, so I have to find where if it's negative.
Okay.
So I take my velocity and I set it equal to 0.
Okay.
And so I'm not liking this one. Hold on.
Use your calculator.
Okay. That's really my y equals. Okay.
Rachel, take your time. Don't ask. Don't ask. Seriously, you can do this. Just pretend you're taking the test. You can do this. Use your instinct. You're great.
Okay. So then I graph it, right?
Mm-hmm.
And I'm trying to find. Okay. So. Okay, it's negative between. Wait, hold on. This is exciting.
It is very exciting, isn't it?
Yes. Hold on.
We only care about the total distance. You can look at the screen from 0 to 1.
Uh-huh.
So, well, you tell me what to do.
Well, you can do that.
Okay.
And press graph.
Okay, is that what you did?
Yes.
Well, here's the graph. I had my window from -1 to 1. All right.
So you find your 0.
How do I do that?
You go to second trace. And find your left bound and your right bound. And then it's 0.357.
So it's excellent, 3 decimal places. Okay, so what does that tell us? We're going to go back to this. So the total distance, no help, try to do it yourself. How would we find the total distance traveled from t equals 0 to t equals 1? How would we set it up first?
Okay, well, you're going to have 2 integration problems, right?
Excellent, Rachel, excellent.
Okay, and so if, I guess if you plug in 0.5 for t on the velocity one, wouldn't that tell you which one goes first?
Right, but let's take a look at the velocity. This is the velocity graph again.
Uh-huh.
Think about this. By looking at this...
Oh, it's like from 0 to 0.357, it's first.
Right, excellent. Sorry about that. From 0 to 0.357, e to the t minus 4t, and then we subtract the other, right?
Right.
Okay, and now how would we find this answer? Because, I mean, we ain't going to... I mean, if we wanted to find the exact answer...
Oh, you print on your calculator, and your y equals.
That's right. Okay, well, let's go through this. Show me what to do here. So, I'm at this screen. What do I do now?
Go to y equals. And then, yeah, Can't you leave it in there?
Okay, then what do? I want to first take the integral from 0 to 3.357.
So you go to math. Oh wait, you have to go to second quit. And then you go to math 9 and then put go to bars and get your y1.
Then what do?
Comma x, comma 0, comma 0.357.
Okay, and then I could just go minus math 9 y sub 1 comma x comma 0.357 comma 1, and there it is.
Yes.
0.6629 or 630. And you know, if you think you made a mistake, you could just go second enter, and that will get the other thing. Rachel.
Yes.
Fine job. You know what I'm going to give you as a present?
What?
I found a picture of you in the future.
Really?
I did. I found a picture. You ready?
Yes.
Here you go. Notice.
Very cute. Very cute.
Notice you still have the math, the love of math.
Yes. I'm loving it.
She does sort of look like you, doesn't she?
Yes. My eyebrows aren't that thin. Yes, but it's.
Well, in the future they fall off.
Oh.
In the future they fall out.
Thank you.
And notice the red dot in the eye is gone.
Yes, it cleared up.
You know, I thought that maybe you went to a different country and got married and they missed.
I'm sure Bhumika's real upset.
That is not funny, Mr.
Bhumika, I was. Is this a matter of fact, Bhumika Kapadia? You know, but hey, Bhumika, have they ever missed?
No.
Okay, because if they did, you know, Rachel would be I'm okay. Hey, listen, call in again, all right?
Okay.
Bye.
Bye.
Great job, Rachel, by the way. Great job. Megan!
Hello.
I feel I sense some,
She's scared.
No, I'm not.
You're scared? Okay. Megan, what's your last name?
Jackson.
Oh, Megan Jackson. How you doing?
Fine.
Why are you so nervous?
I've never done this before.
Okay, I'm going to give you a problem, all right? I'm confident you can do it. You ready?
What does that say?
Say 6.
5. See, it's like you're like two little guys. I don't even know how to teach this. Like if you have two things and then you have 3, 1, 2. I don't know how to teach that. It's pretty sad. Okay, Megan, how you been doing on that velocity PVA stuff?
Pretty good.
Yeah, is that too easy for you?
I don't know.
You don't know?
What?
You don't know if that's too easy for you?
Let's do integrals.
You want to do integrals? Oh, you got Dennis there, huh? Okay, I'll give you an integral. You ready? But you can do it yourself, Megan, because you know Dennis is not going to be there. He won't be there for you on Thursday. He's a love him and leave him type of guy.
We have hand signals and stuff.
Oh, so that's how it works over there. No, look at Miss Harmon. Miss Harmon, we know that you did not teach them. They taught themselves how to cheat. I'm just kidding. Okay, here we go. Hey, let's do something that looks hard but isn't. Actually, let's do something that is hard. Tell me what that is. That's actually really hard, Megan. That's sort of not fair.
Do you just... I don't know what you do. Wait. Do you take the derivative of e to the 2x, and so you just add a 2 up on top? Oh, and then a 1/2 outside?
Okay, I'll tell you what. Let's cheat here. Let's make the problem look like that. That's e to the 2x. Now, what would I do now? Put
a 2 outside, and then put a 1. Oh, I see why you couldn't do that before. Okay.
Right, because if you set u equal 1 plus e to 2x before, du is equal 1 or 2 e to 2x, right?
Mm-hmm.
So therefore, now this is just, well, tell me what to do from here.
You have to put a 1/2 on the outside of the integral.
Okay.
And then it's just e to the, it's 1 plus e to the 2. Well, then you take the integral of the problem and it's 1 plus e to the 2x. Right?
So it's, well, see now you have, this is 1/2 times du. 1/2 times du is e to the 2x. So this just becomes du over u.
Oh, so it's natural log.
Right, right, right. You have to see which formula it fits into. 1/2 natural log of u plus c, or 1/2 natural log of 1 plus e to 2x plus c.
Okay.
You don't need absolute values because it's always positive in that case. Megan, call in again, okay? You going to be there Saturday?
No.
Why not?
I have to go to a competition.
What type of competition?
It's a state competition
A state competition in what?
For literary criticism.
Reading is bad, okay? Math is good.
I think all the English teachers would be mad at you then.
Hey, Miss Gage and I are tight. So Miss G, Miss Gage, we got, you know. Anyway, listen, good luck, and don't forget calculus is your friend.
Okay, thank you.
All right, call in again, all right?
Okay.
Allison Seago.
Hi.
Are you nervous?
I'm very nervous.
Where are you?
I'm at home.
You're at home?
Uh-huh.
Is anybody there with you?
Nope.
Well, I'm glad you called. I'm going to give you a really hard problem because you're really, really smart, okay?
I've been working with Miss Harmon this week. She's very nice.
She is very nice, isn't she?
Yes.
I know. You could thank her parents.
Okay.
You're very nice, too. This is a really hard problem.
Yeah, I just thought you'd change that so it'd be easier.
I know. So, you know what, let's think about this.
Okay.
Let's think about this, okay? And it'll just be, we're going to have a little private tutorial here.
Okay.
All right, so what's your first instinct? Your first instinct is to do what?
Use U substitution.
Okay, and your first instinct would probably set u equal 1 plus e to 2x, and that's a good instinct.
Uh-huh.
Okay, but the problem is it doesn't match up, right? So if it doesn't match up, what else could you possibly, is there anything else that you could set equal to u in this problem?
The 2x.
Okay, but now if we have u equal 2x, we have du is equal 2, and then we got like e to the 1, it still doesn't work out. So you know what happens if it doesn't work out?
What? I have no idea. I'm sorry.
Well, no, that's okay. If it doesn't work out where, you know, it's a normal thing, like you can't set anything equal to u, you do one of two things. Well, first of all, try to factor or expand that, which you really can't. Hello?
Uh-huh.
Or, if not, it's one of the arc things.
Okay.
All right. Now, which one, does this look like one of the arc things? The arc sine or arc tangent?
It might. I'm not sure.
Do you remember the formula for arc tangent?
No.
Okay. Did Ms. Potterberry give you a formula sheet?
I don't think so.
Okay, well, we need to give you a formula sheet. Ask for one this Saturday, okay? Are you going to be there Saturday?
I think so.
Okay. This is it's 1 over a times the integral of du over a squared plus u squared is equal to the arctangent of u over a. I'm sorry, this is 1 over a arctangent of u over a. Do you sort of remember that?
Somewhat.
Okay. Well, this problem, this is u squared right here.
Uh-huh.
So this just comes out to be, if u squared is equal to e to 2x, u is equal to e to the x, then du is equal to...
We can't see it.
du is equal to e to the x.
Okay.
So this is just the integral of du all over 1 plus u squared, which is a formula which is just the arctangent of u.
Okay.
Because it's a 1 there, so it's arctangent of e to the x. Think about this. Do you remember the derivative for arctangent?
No.
Oh, you got to know those formulas. So the derivative of arctangent is u prime all over 1 plus u squared, and this is u. That's the formula for the derivative of arctangent of u is u prime all over 1 plus u squared.
Okay.
So the derivative, so therefore, if we have arctangent of 3x, what would be the derivative of arctangent of 3x?
3 over 1 plus 9x squared.
Excellent. Okay. And what's the derivative of arctangent of e to the x?
E to the x over 1 plus e to 2x.
Okay. And what is the derivative of arc sine? I'm sorry. The formula for arc sine, I'll tell you in a second.
Okay.
The formula, the difference is it's u prime all over square root of 1 minus u squared.
Okay.
Now, do you want to know why these formulas exist?
Sure.
Okay. I'll show you in a second. So if this is the formula, how would you do it?
is your u just x squared, or?
Right, u would be x squared, so what would be the formula?
So 2x over the square root of 1 minus 2x, or x to the fourth.
Right, x to the fourth. Okay, let's see if we could figure out how this thing actually, why it makes sense, okay? Let's say, well, before we do that, I'm going to give you a couple more problems here. Y equals arc sine of 3x squared. Find these derivatives. Y equals arc tangent of sine of 2x. So go ahead and find those derivatives.
Can you put the other sheet back up real quick?
Okay. Yeah. I'll give you a minute to write that down.
Okay. And the arc sine is the one with the square root?
Yeah.
Okay. I got it.
Okay, so what is it?
We put the other one back up real quick. Yeah. Okay. The first one is 6x over the square root of 1 minus 9x to the fourth.
Okay, and then the second one is?
Oh, that is cosine, or 2 cosine 2x over 1 plus sine 2x squared. Sine squared 2x.
Right. Hey, I'm gonna stay on the phone. I'm gonna let Francisco try to explain why these formulas make sense, okay? And then we're gonna come back to you, all right?
Okay.
Francisco!
Yeah.
Hey, do you know why the derivative of arc sine of u is equal to u prime over square root of 1 minus u squared?
I forgot.
Okay. Let's see here. If we have y equals arc sine of u, what's another way to write that? So sine of y is equal to u, right?
Yeah.
So if the sine of y, we could call that the angle. If that's equal to u, it's SOHCAHTOA. That means it's u over 1. And if you figure out this empty side here, it's the square root of 1 minus u squared, right?
Yeah.
So if you had to take the derivative, now remember, we're trying to find the y prime.
Okay.
So if you had to take the derivative, so therefore, if this is the same thing as the sine of y equal to u, this is cosine of y times y prime is equal to u prime.
Mm-hmm.
So therefore, y prime is equal to u prime all over the cosine of y.
Yeah.
Doesn't that make sense?
Yeah.
So we're looking for y prime. Well, we know what u prime is. U prime is u prime, and the cosine of y. Well, in this picture, the cosine of y is square root of 1 minus u squared over 1. So that's how you get that formula.
Oh, yeah.
Right? You see that?
Yeah.
And it's the same way to get the tangent of y. Hey, what type of problem do you want, Francisco?
I don't know.
Pick a problem, any problem.
Related rates.
Related rates. Okay, here we go. Related rates. Wow. Let's say that's going to be hard to make up at the spur of the moment, but so I'm going to have to give you an easier one. How about a rectangle is changing such that the width is decreasing at a rate of 2 inches per second, and the length is increasing at a rate of 3 inches per second. how about find the rate that the diagonal is changing when the width is 10 inches and the length is 7 inches. Okay? Find the rates that the diagonal is changing.
Well, I guess we find the length of the diagonal first.
Well, what are we looking for?
The rate.
The rate of what?
The diagonal.
So how would we write that in mathematical terms? It would be d dt. We're looking for d dt, right?
Yeah.
So if we want to find the rate the diagonal is changing, if we need to find the rate that the diagonal is changing, what are we looking for? What do we need to find? What do we need to have? We need to have an equation with what?
dw.
We need to have an equation with d in it. If we have an equation with d in it, we could find d dt, right?
Yeah.
By the way, I'm going to make this. Well, we'll just leave it like that. Okay, so if this is 7 and this is 10, well, what's an equation with the diagonal in it?
Pythagoras here.
Okay, very good. And what? So that'd be d squared is equal to w squared plus l squared, right?
Yeah.
Now, how would you find? Now, what would you do? How do you take the derivative with respect to t of this problem?
2 d dt is equal to 2 w dw dt plus 2l dl dt.
Okay, excellent. So all we need to do to find the answer is we need to find d, w, dw dt, l, and dl dt. Well, we have w and l, and we have dw dt and dl dt.
Yeah.
So how would we find d?
Plug in numbers, divide by. We already know w and l. So
Right, it's just square root of 149, right?
yeah.
So therefore, you plug in all the numbers and you'd solve for d dt.
Yeah.
The key to related rates, Francisco, the key to related rates is that if find what you're looking for, in this case d dt, that means you have to write an equation with d in it.
Yeah.
Okay?
Mm-hmm.
Hey, great job. We'll see you Saturday, okay?
Okay.
Allison? Allison?
Yes.
Was that fun?
Yes.
Okay. Hello?
Uh-huh.
Do you hear that busy signal, or is it okay? I want to. So let's go over just real quickly.
Okay.
So those formulas, and we need to get you a formula sheet.
Okay.
Arctangent. It could also look like that. Inverse tangent. Hello.
Uh-huh.
I'm trying to get there.
Okay.
Y prime is equal to u prime all over 1 plus u squared. And the reason why this makes sense is because if you have y is equal to arctangent of u, if you take the tangent of both sides, and our goal is to find y prime.
Mm-hmm.
That's what we want to find. The tangent of y is the tangent of arctangent cancels out is that. And if we take the derivative of both sides here, first of all, we can draw a picture. The tangent of y, the tangent of an angle, is equal to u, and tangent is opposite over adjacent.
Mm-hmm.
SOHCAHTOA. Do you remember? You know what I'm talking about?
I know what you're talking about.
And this is square root. I'm sorry. This is just. It's square root of 1 plus u squared.
Okay.
So that's what the picture looks like for a tangent of y equal to u. Now, if we were to take the derivative of this, what's the derivative of tangent of y?
Secant squared y.
Times.
Dy, I don't know.
Right, times y prime. You're
Okay.
right. And the derivative of u is u prime. So y prime is equal to u prime all over secant squared y. And secant squared y is the same thing as 1 over cosine.
Uh-huh.
Well, cosine of y in this picture is this over this.
Okay.
So 1 over cosine is just that. So let me take that slowly. Secant squared of y is equal to secant of y quantity squared, which is equal to 1 over cosine of y quantity squared. Well, cosine, it's 1 over cosine of y is 1 over square root of 1 plus u squared. So 1 over that is equal to just 1 plus u squared. You sort of see that?
Yeah.
So therefore, that's why the formula makes sense. It's u prime all over 1 plus u squared.
Okay.
So, I mean, but the main thing is you just need to memorize the formulas.
Okay.
Okay. We need to get you a formula sheet. Hey, Allison?
Yes?
The other thing is the practice problems in the blue binder and stuff, have you been working through those?
More in the red binder.
Okay, go through the blue binder too, because those are old practice tests.
Okay.
And you can see how you do. If you take like in the blue binders the 1997 practice test, have you taken that yet?
Yeah, that was our final we took this week.
How many did you get right on the multiple choice?
I don't know. My total score is an 88.
Wow. I mean, did she grade it? Did you have free response also?
Yes. That was my favorite part.
Okay, wow, that is fantastic. So, approximately how many did you get on the multiple choice?
Oh, I don't remember. I'm sorry.
I want to show you something here.
Okay.
Okay, to get an 88, that would be a 5. You know that?
No. Yeah, well, now I do.
All right, the way the scoring is, you need around 70 points for a 5, 55 for about a 4, and it varies a little bit each year.
Yeah.
And you take the number of there's 45 multiple choice questions, number of multiple choice right, minus 1/4 of them wrong, however you got wrong, and you multiply that times 1.2.
Okay.
And then each free response is worth 9 points. So this is worth 54 points. There's 45 multiple choice questions. If you got them all right, 45 times 1.2 is also 54. So the whole test is worth 108. So let's say if you want a 5, let's say you got 32 right, 8 wrong, and 5 blank. And let's say on the free response you really knew one of them well, and then you knew a couple other really pretty good, and then you just got some points on one of those and 2, and let's say you got a point on those. So you sort of really just knew 3 of them, and the others you just were able to get through. Let's see how many points this is worth.
Okay.
32 minus 1/4 of 8 is 30. Times 1.2 is 36 points. 16, 23, and 7 is 30. This would be a mid 4. So let's say that instead of the last 3, so you would need let's say you knew these pretty well and you didn't know one of them at all. This would be 28 and 37 points. So that would be a 70, or let's say you just got 4 on this. This is 21, 30, 35, and this would be 71 points, which would be probably a low 5. So one of the problems you didn't know at all. One of them or 2 of them you were able to get just a little bit less than half credit, and you got 32 of them right. Okay. So I mean, getting a 5 is a real attainable process, is what I'm trying to say. But you'll need in the low 30s right, okay? And about 3.5 of the 6 problems, okay?
Okay.
Allison? I'll see you Saturday.
Okay.
All right?
Thank you.
Have a good couple days, okay?
Okay.
Y'all, good luck, everybody, on the test. We'll see you Saturday, and don't stop studying. It's not too late. Talk to you.
Down the street is trying hard to learn their song. Serenade the weekend squire who just came out to mow his lawn. Another Pleasant Valley Sunday. Charcoal burning everywhere. Rows of houses that are all the same, and no one seems to care. See Mrs. Gray, she's proud today because the roses are in bloom. Mr. Green, he's so serene, he's got a TV in every